So today's lecture is really about multivariate graphs, and so this is graphs with 3 or more variables. Yeah. So in the first week we looked at the distribution of particular variables. You can look at a histogram or a box plot and see how one variable is distributed. Then the second week we looked at how to look at a relationship between 2 variables. And today I want to talk about how you can look at the relationship between 2 variables separately for separate groups. Or with different colors for different groups, or different sizes for different, based on a variable, etc. But what I want to now talk about is not so much how to do that, because that's in the lab and in this video that I uploaded. I want to talk more about why you might want to do this. Yeah. So what is the point of doing these multivariate graphs? And I suspect that if you have done any kind of methods course before, so you might have done my own Foundations of Political Research module, or you might have done Analytical Sociology module in year 1, or you might have done some economic analysis module. If you've done any kind of methods module, you will have had this before. So it's not, I'm hoping that it's not new to you, and that's why I'll do it relatively quickly, but just to make sure we're all more or less on the same page. So I just have a quick example, including the R code, which is just looking at, so last year, instead of the Irish National Election Study, we had the Brexit data set. So this example is from the Brexit data set. The lab goes back to the Irish National Election Study. And it looks at the relationship in the referendum between how much attention people pay to politics on the x-axis and how much they are in favor of European integration on the y-axis. Yeah, among voters in the Brexit referendum in the UK. Yeah, and we see a slight positive relationship. People that pay more attention to politics, more likely to be in favor of European integration. So this is a bivariate plot where we look at 2 variables and the relationship. Now, the key point that I want to bring home is that that you have to be very careful if you want to make any kind of link between seeing a correlation and thinking that one is the cause of the other. And as I said in the first lecture, we are not going to discuss extensively causal inference. So for us in this course, this is always a little bit of a side story. We are not looking at good methods to do causal inference. For that, there are many other modules that you can take. Instead, I want to look at, we are in this module looking more at sort of how machine learning and data science can be applied to social science. And machine learning and data science tend to, there's a trend in the opposite direction, but tend to not be so concerned with causal inference. But just, so this is really a bit of a sidestep, but just to make sure that we're more or less on the same page. If there is a correlation, if there is an association, there might be a causal relationship, but there might also very well not be a causal relationship. Yeah, there can be other factors that play a role that will affect whether you see a relationship or not. And it can be because of some third variable that you might be missing, or it can be for some other reason. Here's an example of some other reason. So let's see that we want to test whether a particular drug helps to reduce, to improve the health of some sick patients with a particular illness. So, and we might find a relationship, right, between how much the people that use the drugs or not, and whether they recover faster or not. But there are 2 problems that might obscure this relationship. First of all, if the healthier patients in your sample decide to stop taking the medicine because they're already feeling well, you give them some medicine to take. So imagine you do an experiment. You divide all your patients in 2 groups. You give half of them the real drug and half of them some fake drug, yeah? The placebo. And you just want to see whether the effects are different, yeah? Whether the drug is helping. Now, if the healthier patients, the ones that are already feeling quite well, stop taking the medicine altogether because they already feel well, they don't want to take extra drugs, then that might slow down their recovery, right? So they might feel a little bit better, but not be fully recovered, and then this slows it down. So you might maybe find a relationship even if the drug is not working. Yeah. Oh, sorry, that's the second example. Sorry, I confused myself. So if the sick patients take a drug and the healthier ones do not, then you're not going to find much of a relationship, even though there might be one, right? Because among the ones that take the drug are the sicker patients. Or in the other way around, if the healthier patients do take the drug, but the sick ones feel too sick and for some reason they don't take it, then we might find an association even if there isn't one. Yeah, so this relationship between taking the drug and recovery is going to be obscured by actually their health status and how that changes their behavior. So you can't just trust these relationships. Now, in social science, we're more looking at sort of these third variables that might play a role. So causation is a very complicated concept that many philosophers debate about how exactly to define that. We're not going to go into that discussion. But very crudely speaking, people tend to have the following 4 requirements for something to be a causal effect. The first is that the cause should come first, and the effect should come later. Yeah? So something cannot be caused by something that is only going to happen later. The outcome variable, the dependent variable, and the explanatory variable, the independent variable, they should correlate. They should be related to each other. Yeah. We expect if there is a causal relationship and we look at an association, we should find an association. But if there is this causation of the correlation, we should also not be able to come up with a third variable that explains this correlation. Yeah. So we should not have a third variable that if you look at different categories of that variable, you suddenly don't see a relationship anymore. Or in the previous example, we even saw how a relationship can be obscured because of a third variable. So sometimes we don't see a correlation, but if we take a third variable into account, we do find a correlation. So we need to establish that it's not because of some third variable. And finally, there should be some kind of theoretical or logical reason why we think the one is a cause of the other. Yeah, so causal relationships cannot directly be observed. They are a theoretical concept. They are part of our understanding. We also need to have an explanation of why the two are correlated. And so this third bullet point is really the core of today's class, right? So we can look whether there's a correlation. We have looked at the second bullet point last week. Now we're going to see if there's no third variable that maybe explains this relationship. So if I go back to, I will go back to these slides, but if I go look at the earlier example, we looked at whether there's a relationship between attention and attitude towards European integration. We might want to add party choice in the mix, for example. Then we can make separate plots. And for each, so we asked voters also what party they vote. And for each party, we can also see if there's a relationship between attention to politics and support for European integration. And then you see that this relationship that we saw on average actually radically changes depending on the party. Yeah. So there is still relationships, but it really differs. So among conservative voters, if they pay more attention to politics, they are less likely to be pro-integration. But among Labour voters, if they pay more attention to politics, they're more likely to be pro-integration. And it might look confusing, but it might actually also be quite logical, right? In the sense that maybe it's not the case that people that pay more attention are more in favor of European integration, but people that pay more attention are more likely to be aligned with the party they choose, right? So they follow politics better, they know better what their party stands for, and they might then also follow the cues of the party better, so they align themselves better. And so if Labour is more in favor of integration and Conservatives are more against integration, those voters that pay more attention might be more aligned. And that might then be the real explanation, that it's not about more attention is more integration, but more attention leads to more alignment with the party. Yeah, and then you get a whole different story. Now here's another example, and also just to get the terminology a little bit right. So first of all, in this causal literature, they're not normally talking about independent and dependent variables. They tend to talk more about treatment and effects, but it boils down to the same thing. And so we are trying to establish that there is a causal factor, a treatment, and that this leads to a particular outcome or the effect. And we are checking whether there are any confounders, any third variables that might explain both the independent and the dependent variable, the treatment and the effect. Yeah, and so and that we call a confounder in theory. And if we add a variable to the model to capture this confounder, we call it a control variable. So a control variable is a third variable we add to the model to see if the association still holds. So we can make one plot where we see if there's a relationship between the treatment and effect, and then we can make separate plots for separate categories on the control variable. Yeah. So the lab shows you how to do all these multi-way graphs, but this is kind of the main purpose. So to give an example, the numbers here are just made up. They're nonsense. So we might think that political knowledge of politics will have an effect on whether you turn out in an election. Yeah. So we might expect there's a relationship, and we might make a table to see if there's a relationship. And we see indeed that, well, we see that those with low levels of knowledge are less likely to turn out than those with high levels of knowledge. Yeah. So in this case, 90% of those with high levels of knowledge turn out to vote, and 70% of those with low knowledge. So we see a relationship. Yeah. But you might argue that we need to look at interest in politics, because people that are more interested in politics are more interested in politics, are more likely to acquire information about politics, so to become more knowledgeable, but they are also more likely to participate in politics. Yeah. So this is an important control variable. If you want to know the relationship between political knowledge and turnout, you should control for levels of interest in politics. And then we can make two different tables, one with high interest in politics and one with low interest in politics, and see if the relationship holds. Right? And then among those with high interest in politics, they all turn out whether or not they have high levels of knowledge. And those with a low interest in politics, they are all less likely to turn out, only about 60%, regardless of whether they have high or low levels of knowledge. So this is a good example where in a bivariate plot you see a relationship, and you would argue that there is a link between political knowledge and turnout. But if you look separately for different categories for the control variable, you see that the relationship disappears. So if we go back to this slide, we can say there is a correlation between dependent and independent variables. So bullet point 2 tick, we can tick the box. But we can come up with a third variable, namely interest in politics, that explains this correlation. Yeah, and there shouldn't be such a variable if there is a causal effect. So we can then argue that this shows there is no causal effect between political knowledge and turnout, because there is a third variable that explains the relationship. Now in this case, it's very stark, like that's why it's an artificial example. You won't find it so clearly in real data. It's just to show you the point. Yeah? Are there any questions about that, what this does, the control variable? So that's a really important thing to think about for the presentation next week as well. Yeah. So you want, in your head, you definitely want a graph like the one on top here, like a plot. You want to think about what is my causal variable, what is my dependent variable, and what is control variable, and present that in the slides. Yeah. So here's the code, just so you understand how to make this kind of plot, and that's what we will do in the lab as well. So this is we have a ggplot library. We take the Brexit data set, we put attention on the x-axis and pro-integration on the y-axis. Then we jitter all the data, so all the points are moved randomly a little bit, so it becomes more visible where they are. The alpha value is a transparency value, so we can see when points are on top of each other, they become darker, and when they're separate from each other, they don't, so we can see better where they are. And then we have these GM smooth method SLM means that you get a straight line, a regression line through this plot. And the facet wrap, it means that we are splitting by party, and we put it in different cells. So I would suggest you can see, can you see my mouse? Actually, I can just draw. Right, so all these slides here, they are helpful to have as a next to you when you do the lab, because they explain the different features that you can change. And you can also look at this example here, but it's also explained in the lab itself, but it's helpful as an extra reference.